So, hello once again, and today we will be studying some important terms related to the spherical mirrors, that is, concave mirror and the convex mirror. Children, as you know, that a concave mirror is that mirror is that spherical mirror that has its reflecting surface curved inwards. Okay, and convex mirror is a spherical mirror that has its reflecting surface curved outwards. And now, before studying how the reflection of light takes place when the object is kept at different positions, before that, you should be aware of these important terms, that is, center of curvature, focus, principal axis, pole, focal length, and radius of curvature. So let's study these important terms with the help of the diagrams. The first term is center of curvature. I have already told you that a spherical mirror is a part of a hollow sphere, a hollow sphere, or I can say that a spherical mirror is that mirror whose reflecting surface is a part of the hollow sphere of a glass. So, what will be the center of curvature? It is the center of the sphere of which mirror is a part. For example, in this figure, this is a convex mirror and this is the concave mirror. So, this convex mirror is a part of this sphere. So, center of curvature is the center of the sphere of which this mirror is a part. In the same way, the center of curvature is the center of the sphere of which this concave mirror is a part. Okay? It is denoted by letter C. Now, radius of curvature. Or we can say, okay, it is the radius of the sphere of which mirror is a part. Simple. Now, this is the sphere of which this mirror is a part. So, this will be the radius of the sphere. And if we consider this mirror, then this will be the radius of the sphere. Okay. Now, what is the pole of the mirror? Pole of the mirror is the center of the spherical mirror. See, this is mirror and this is the center of the mirror, that is, and it is known as pole, P for pole. Here, this is P for pole. Okay. Now, what will be the radius of this mirror? That is CP. Here, CP will be the radius of the mirror. Okay. Now, another term, that is principal axis. Principal axis is the straight line passing through the center of curvature and pole. Okay, let's see what is principal axis. It is the straight line passing through the pole and center of curvature. We can say XY. Here is a principal axis, and here XY. The line passing through the center of curvature and pole is called principal axis. Okay. So, and now let's study another term, that is principal focus. This is very important term. For studying principal focus, let us imagine that that parallel beams of light, they are falling on the concave mirror. So when these parallel beam of light, parallel beam of light means bundle of rays. Beam means bundle of rays. So parallel beam of light rays, they are incident on the concave mirror. So after reflection, see, it is reflecting. This ray of light is reflecting like this, and this ray of light is reflecting like this, and this ray of light is reflecting like this. So we are seeing that all the rays, they, after reflection, they are meeting at one point. Or I can say that all the rays, they are converging at one point, and this that point is known as principal focus or focus. It is a point on the principal, and where it lies, what is the location of the focus? It is on the principal axis. That is why it is known as principal focus. So, principal focus is a point on the principal axis where all the rays parallel to the principal axis converge. Okay, so that's why the concave mirror is also known as the converging mirror, because it converges all the rays, that is all the parallel rays of light to one point called focus. Now see, we have already studied about the real image and the virtual image. Now you can see that all the parallel rays of light, they are actually meeting at one point, that is focus. So concave mirror has a real focus. Now let's see focus of convex mirror. It is the point on the principal axis, same as concave mirror, where the reflected rays appears to converge. Now see, the parallel rays of light, they are incident on the convex mirror. After reflection, what happened? See, they are reflected back. In this way, they are reflected back. In this way, they are reflected back. In this way, they are reflected back. Okay. So they are actually diverging. They are actually diverging. Diverging means वो फैल रही हैं. But if we produce them backwards, they are they appear they appear to converge at one point, and this point, this imaginary point, is known as focus. So convex mirror has virtual focus. That means virtual means the rays of light, they do not actually meet, they only appear to meet at a point. So that point is a virtual point, it is in the imagination. So this is principal focus. Now what is the focal length of the spherical mirror? It is the distance between the pole and the principal focus is called focal length. So let's find out. This is focus F and this is pole. So the distance between P and F is the focal length, and it is denoted by small f. In the case of concave mirror, this is the FP is the focal length. So earlier we studied about the radius of curvature, and now we studied about the focal length. Now let us find out what is the relationship between these two terms, that is radius of curvature and focal length. The relationship is like this: the radius of curvature is 2 times the focal length of any spherical mirror. That means focal length is equal to r upon 2, radius divided by 2, or we can say r is equal to twice of f, focal length. This is the relationship between the two terms, that is radius of curvature and the focal length. Now for studying further the formation of image by the concave mirror and the convex mirror, you should be aware of the rules for reflection of light through the spherical mirrors. There are certain rules which will help you in making ray diagrams. The first rule is that if in a concave mirror a ray of light parallel to the principal axis after reflection will pass through the focus, or see in the figure also what is the, let me find out in the book if it is given in the different language. Let me find out. Okay, a ray of light, see, I'm speaking again, a ray of light which is parallel to the principal axis of the concave mirror passes through the focus after reflection from the mirror. It is reflected here, and while reflection, it passes through the focus. This is first rule. Now, in case of the convex mirror, the rule is same, only the diagram is different. The ray of light which is parallel to the principal axis of the convex mirror appears to be coming from the focus after reflection from the mirror. तो रिफ्लेक्ट तो वो यहाँ से हो जाती है, लेकिन अगर आप उसे पीछे की ओर प्रोड्यूस करेंगे तो आपको लगेगा कि ये फोकस से आ रही है. सो दिस इज़ द फर्स्ट रूल. पैरेलल आएगी, रिफ्लेक्शन होने के बाद वो फोकस से निकलेगी. सेकेंड रूल, द रे ऑफ लाइट passing through the focus, it is actually second rule is the reverse of the first rule. The ray of light passing through the focus of the concave mirror becomes parallel. See, after reflection it becomes parallel to the principal axis. This is second rule. Okay. In case of convex mirror also, there is ray of light. See, ray of light. Now this we will consider this ray. The ray of light which is incident, which is going through the focus of the convex mirror becomes parallel to the principal axis after reflection. So, dear children, don't get confused. The more you practice, the more you will become perfect. You all know that practice makes a man perfect. So, the third rule states that the ray of light passing through the center of curvature of the concave mirror is reflected back along the same path. So, in case of convex mirror also, see, this is the figure for the convex mirror. The ray of light passing through the center of curvature of the convex mirror is reflected back along the same length. Please take care of the arrows while drawing the ray diagrams. And the last rule is that a ray of light which is incident at the pole of the focus mirror, pole of the concave mirror, is reflected back, making the same angle with the principal axis. And in case of convex mirror, it is same. The ray of light which is incident at the pole of the convex mirror is reflected back, making the same angle with the principal axis. So these are the important terms and important rules which you should remember and also practice by making ray diagrams again and again so that you become perfect. And this will certainly help you in understanding the formation of images by the two mirrors, that is convex and concave, and also in drawing the ray diagrams. Thank you so much and all the best for the next sessions.